Good afternoon, math fans. Good anytime, math fans. This is a video, so you're going to see this whenever you load it. So it's afternoon, morning, nighttime. It's never a bad time for math. All right, so we are going into graphing parabolas of two forms. We're going to look at a few forms, actually, not just two, three forms. We're going to start with our very first parabola, y equals x squared. We're going to look at, hey, how does that change? We're going to look at y equals x squared plus some number k. We'll talk about what that k does. And we're going to look at y equals some value times x squared plus k. So we're going to look at those three forms. And these are all quadratic functions, right? So they're all quadratic functions, and they're quadratic because that's coming from that being an x squared, right? So that's coming from x squared. And these shapes, they create these functions, they create a shape on a graph called a parabola. And we're going to see what a parabola looks like. So they create a shape called a parabola. Let's get a ruler out here. We're going to need it eventually, but we won't need it right away. Where did that go? I don't see it show up here. We'll find it in a bit. Okay, just give me a moment. I'm just going to pause this and I'm going to reload. All right, we're back and the ruler is with us now. Good, we'll need that in a little bit. So the first thing we're going to do is just graph this basic parabola. So our first example here is example 1. We want to graph f of x, so some function with variable x, and that makes our y values, and the function itself is x squared, right? We want to graph f of x. Actually, let's do it in the other order. That's more mathematically accurate. Our y values are some function of x, and that function is x squared. And we're going to use some values between negative 3 and 3, just to center things and see where they show up. So first off, let's just see what happens here. We're just going to say, let's look at our x values. So this is x, and this is f of x equals x squared, and this makes an xy coordinate pair. So let's look at it for values of negative 3, negative 2, negative 1, 0, 1, 2, 3. Well, this will just be negative 3 squared, making it 9. This will be negative 2 squared, making it 4. And this will be negative 1 squared, making it 1. This will be 0 squared, making it 0. This will be 1 squared, making it 1. This will be 2 squared, making it 4. This will be 3 squared, not 3 cubed. Ooh, got away from myself there. Making it 9. Good. Now, when we put this together, the ordered pair for this, right? So the xy coordinate pair that we see here, right? The xy coordinate pair, this will be negative 3 and 9. This will be negative 2 and 4. This will be negative 1 and 1. This will be 0 and 0. This will be 1 and 1. This will be 2 and 4. This will be 3 and 9. Now, notice that all our x values change by 1, right? So x changes by 1. X changes by 1. And now if we start at 0, y changes first by 1, then by 3, then by 5. Take a minute, pause this, and see if you think what the next change will be. What's 4 squared? Well, it's 16 minus 9, right? So what's the next change going to be? All right, pause it for a moment right here. Answer the question. What is the next value of change going to be? All right, welcome back. So it is going to be 7. 16 minus 9 is 7. Well, the next one, 5 squared is 25. 25 minus 16 is 9, right? As we go along, the parabola increases by the next odd number. It increases by more every time we get further out from 0. The x change always keeps happening. So what this means is that we're not going to graph a line anymore. We are going to be graphing some sort of curved shape because the growth keeps growing faster and faster. Let's actually sketch it out and see what happens. So let's make our graph. Let's make a coordinate plane here. So we'll just make our xy plane with an x-axis and a y-axis. So let's just get a ruler. I like making them from scratch. I know I can do it in the program, but I can like to make them here. And I can go there, do this. Throw it in there, x, y. And at the origin, this is 0, 0, right? That's our point 0, 0. Here, this is 1, 1. This is negative 1 and 1. This is 2 and 4, right? That's 2 and 4. Our x value of 2, y value of 4. This is negative 2 and 4. And it would keep going to 1, 2, 3, 4, 5. This would be 3 and 9. And there was going to be some symmetry to get to negative 3 and 9. But I don't want to write over what we have there. But this will make this kind of shape here of this kind of bowl U shape there. And you can just use little lines to kind of get what you're doing. We're going to use these arrows to indicate that it goes on forever, right? We're going to use these arrows to indicate that it goes on forever. But the shape that it makes here is a parabola, right? So this is a parabola. A few interesting things that we want to note about this parabola. One, it opens up, right? Opens upwards. 2, right? So the branches point going to positive y, right? So it's going y positive, right? It's going towards the positive y values. That's what opening up does. Has in axis of symmetry. So let's talk about what axis of symmetry means. So symmetry is when something can be mirrored. So here, all these y values are mirrored on the vertex. So the vertex is this bottom minimum point here, and we'll talk about that. This vertex it tells us that every point from this axis here, if we were to put a mirror on this line right here and look into that mirror, and we were to put a flat vertical mirror right on top here like that, right? If we put a mirror on there like that, the reflection we would see in the mirror is the other arm of the parabola. It would look like nothing has changed even if we put a mirror down. And with that symmetry means that everything is equal distance out from those points, right? Everything is equal distance out. That's 1 and 1, that's 2 and 2, that's 3 and 3. So axis of symmetry means we have equal points. And this is going to be relevant in helping some of our solving later on. So axis of symmetry often gets to be AOS, right? So actually, let's put the bracket here. This is AOS. And this is going to be the vertex component of x. So the axis of symmetry is often the x value of the vertex. So x value of vertex. And we're going to talk about moving vertexes later. We won't talk about it in this lesson, but we'll talk about it a bit later. So x value of vertex. Further, what else is happening here? We do talk about the vertex. The vertex is, it is going to be lowest or highest point. And point is kind of like a turn or corner, right? Where it goes from one arm to the other arm, right? And so this is like a minimum and maximum, where a minimum or maximum on the parabola. And when we think of a parabola, it's always centered on that vertex, right? So it's always centered on the vertex. For this one, this is a minimum, and every point is higher than that vertex. We're going to see somewhere it can be a maximum. We're going to think about domain. So domain for us means that this is x is all real numbers. So x can be any number. There's nothing that we can't square. We can square 0, we can square 1, we can square -1, we can square pi. We can square 1,000,000, we can square 1,000,000,000, we can square 1/2, we can square -1/2. We can square anything. Give me a number and I'll square it, right? It's something that shows up. We can write it as x can be any real number. We can write it as an interval from -infinity to infinity. Or we could say x is between -infinity and infinity. And we use the strictly greater than, strictly less than, because we can't have a number equal to infinity. X is, right? If we have to take a peek and see what is, like anytime we say we're close to infinity, right, we can always pick a bigger number. So nothing can be equal to infinity, but things have a relationship with infinity. Okay, next up is range. So where domain was concerned with x values, right, the possible x's, so this is x values, possible x's for domain. When we talk about range and when we consider range, range is about the y values we can have. So here, when we look at the y values, I don't have any y values here, right? There's no y values here. There's not, my function doesn't make anything. But as soon as I'm at 0, 0, I have a y value there, y value here, y value there, y value here. So from 0 going up to infinity, I have y values. And I'm including 0 because it starts at 0. So I do have y values occurring. So y has to be greater than or equal to 0. All my function values start there. I could also write this as from 0 to infinity like that. So there's a couple ways I can write that. It's not all real numbers. Y can't be any negative number, right? No y show up there. When I look at domain, domain can be anything here. If I were to put this value in over here, if I were to put in 1, 2, 3, 4, 5, 6, 7, 8, well, 8 squared is 64. I can't graph 64 all the way. My grid doesn't even go that high, but if you had a grid that it could fit, it will. So range is the y value output, right? So our domain is what we put into the function, and our range is the y values we get out of it. Okay. So let's see, what time do we got here? Do we take a break? Yeah, we take a break. All right, we'll see you in the next one.